everybody, welcome back. We are taking a look at lesson 3 today, gravimetric stoichiometry. Basically what gravimetric means is it's referring to mass. So we're going to be looking at grams of unknown and known entities in a reaction. The learning goals for today are to understand that every entity in a chemical reaction are related through molar ratio. Write a stoichiometry statement to calculate unknowns in a reaction. Okay, I'm going to go through the basic anatomy of a stoichiometry statement. So the general way in a gravimetric stoich problem is you're usually going from one mass of a known to a mass of an unknown entity in a reaction. So this is how it is. You're going to start off with a mass of your known. Okay, you're going to start off with your known mass. Usually it's in grams. Sometimes you might have it in kilograms. Then you will convert that into your known moles. Okay, usually it's measured in moles. Sometimes it's kilomoles. Sometimes it is millimoles, but depending on the problem. Now, ask yourself, how do I get from a mass to moles? We're going to get there by using molar mass. Okay, once we have our known moles, we can then convert it into our unknown moles. When we're converting from one entity in a reaction to another, we will use the converter of a molar ratio. Lastly, once we have the moles of our unknown, we can then calculate our unknown mass. And that is done, again, whenever you're going from moles to mass or mass to moles, the converter that we will be using is molar mass. All right, let's put our knowledge to use. Example 1, copper metal reacts with a solution of silver nitrate. Okay, so it says it's in a solution. That means we're going to have to check to see if things are aqueous. To produce silver metal and copper nitrate. What mass of silver can be produced by reacting 0.25 moles of copper? Great. So, first thing that we do in all chemistry problems so far is we write a balanced reaction. Okay, so we've got copper metal, it's going to be solid, plus silver nitrate, which I checked on page 6. It is aqueous. And it says once those two react together, it produces silver metal and copper 2 nitrate. I checked on page 6. This is also aqueous. Step 2 also may seem very familiar to you, is you're going to list the known and the unknown values under the reaction. Let's go back up to our problem here. It says that what mass of silver, so we are looking for grams of silver, are produced by reacting 0.25 moles of copper. So our known is 0.250 moles of copper. Okay, so this here is my known. And this is my unknown. Okay, there's step 2. Now, step 3 is to write a stoich statement. You're going to start off with what you know. I know, so we are looking for mass of silver. You're going to start off with your known value. 0.250 moles of copper. Now, if I go back up to my flow chart here, actually, I'm going to draw the flow chart down here. So we go from mass of known mass to known moles. Okay, so here's the flow chart that I talked about above. You don't need to use the flow chart every time, but I'm just showing it in the early stages so you can see what's happening. So you start off on the main end with known mass. If we look at our known, we are actually given moles. So there is no known mass. We can actually get rid of that step. We don't need to convert it into moles. We already have it in moles. It saves us a step. So that brings us here to our known moles. We then need to convert our known moles to our unknown moles, which I said happens through using molar ratio. One thing I forgot to do in my balance reaction was actually balance it. So you're going to get 2, 2. There we are. We are now balanced. We can now use our balanced reactions to write our molar ratio. There is, there is 1 mole of copper and 2 moles of silver. Okay, now I'm going to show you the cancellation. Moles cancels out with moles. Copper cancels out with copper. So from here to here, I now have my moles of silver, which is my unknown. Okay, Stoich is like writing a sentence. Then I need to find mass. We are looking for mass of silver. Okay, and the way that we're going to do that is use the molar mass. Now, the molar mass of silver is 107.87 grams per mole. Now I'm going to grab another color here to show you the cancellation. Mole cancels out with moles. And now from here to here, I have mass of silver, which is my unknown. Okay, so sometimes it may ask you to find mass of your unknown, might ask you to find moles of your unknown. Once I plug this all into my calculator, I get an answer of 53.9 grams of silver. There is my final answer. Let's try another example. Example 2, how many moles of calcium phosphate precipitate are produced when 7.5 moles of calcium nitrate are reacted in solution with excess sodium phosphate? Okay, step 1 is a balanced reaction. So we are having calcium nitrate is reacted with sodium phosphate. So CaNO3, 2. That is going to be aqueous plus sodium phosphate, Na3PO4, aqueous, produces calcium phosphate, which is a precipitate. so it's going to be solid in solution, plus this is a double replacement reaction, so it's going to form sodium nitrate, which is aqueous in solution. Okay, let's balance this. Take a moment, pause, balance it. For those of you who need a refresher of how to balance, you can follow along, or if you are comfortable, then you can fast forward. I list all of the entities: calcium, nitrate, sodium, phosphate. I have 1 calcium, 2 nitrates, okay, because of that bracket there. Sodium 3, phosphate 1. Now on the product side, I want to list them in the same order: calcium, nitrate, sodium, and phosphate. The reason being is because I want to be able to quickly cross-reference these, and so it's easy when you have them on the same line. Okay, calcium on this side, 3, nitrate 1, sodium 1, phosphate 1. Okay, first thing, I cross-referenced the first line and calcium is not matching up, so I'm going to give that a coefficient of 3. When you are giving a product or an entity a coefficient, you are multiplying. Whenever you put a coefficient in front of an entity, you need to recalculate. So now I have 3 calcium and 6 nitrates. 3 times 2 gives me 6. Okay, so now I see that my nitrates don't match up. So I'm going to go over and give my nitrate a coefficient of 6. Okay, so now I need to recalculate. I have 6 nitrates and 6 sodiums. Okay, now sodium isn't matching up, so I'm going to go back on my reactant side and put a coefficient of 2, because 2 times 3 gives me 6. Phosphate also, I now have 2. Okay, now my phosphates don't match up, so I go back on the product side and put a coefficient of 2. 2, and then I realize my mistake. Calcium has a charge of 2, so this should be 2 phosphates. Fixing it. Okay, so there needs to be no coefficient in front of that. Okay, lovely. So everything is now balanced. Okay, after the balancing, we are then going to list our known and unknown values. My known is that I have 7.5 moles of calcium nitrate. 7.5 moles. Okay, so this is my known. Okay, you can have knowns on the product side as well and work back to the reactants. A lot of students think that you only can have reactants that are known. Okay, and then we are looking for how many moles of calcium phosphate is created. So that's this guy here. We're looking for blank moles. Great, this was step 2, listing your known and your unknown. Lastly, step 3 is your Stoich statement. Okay, I'm going to just put the flow chart up and I'll be right back. Okay, here is our flow chart: known mass, known moles, unknown mass. Okay, so our known is actually starting off as moles. So we don't need to convert our mass into moles. We already have moles. So we are looking for moles. So we're going to start off with our known, 7.5 moles of calcium nitrate. Okay, we are then going to convert this into our unknown moles using a molar ratio. I have 3 moles of calcium nitrate, and we are looking for our unknown, which has a coefficient of 1. Ones are invisible in chemistry. Calcium phosphate. Okay, we're looking for moles. So we can take this step out of our flow chart as well. We are not looking for mass, we are looking for moles. Now, let's do some cancellation. Moles cancels out with moles. Calcium nitrate cancels out with calcium nitrate, and we are left with moles of calcium phosphate. Once I plug this into my calculator, I get a final answer of 2.5 moles of calcium phosphate. Okay, there's my final answer. Okay, you're going to try this one on your own. If 4.5 moles of calcium borate precipitate, PPT is another word for precipitate, are produced by the reaction of potassium borate with excess calcium acetate, how many moles of potassium borate reacted? Okay, so I'm going to give you guys a minute to list your known and your unknown. They've already provided a balanced reaction, and I want you to tell me how many moles of the precipitate forms. So you can unpause when you're ready to check your answer. All right, here is our answer. So our known is actually on our product side this time. So I started with it. Then I realized that we needed to go from moles to moles. So moles cancels out with moles, calcium borate cancels out with calcium borate, and then I am left with moles of potassium borate. Once I plug this all into my calculator, I get 9 moles of potassium borate. Example 3, I'm actually going to show you 2 ways to do example 3. Aluminum oxide decomposes to aluminum and oxygen gas. What mass of aluminum can be produced from 2.04 kilograms of aluminum oxide? Give your answer in the form of AB dot A dot BC times 10 to the D. Okay, this is something that I will address as well. Most of us have grasped this concept of a numeric response problem. However, some of us are still a little uncomfortable with it. So we are going to address that at the end. Okay, first step, step 1, is a balanced reaction. So we're going to write this down. Aluminum oxide decomposes. Aluminum oxide decomposes, so that's breaking down into aluminum and oxygen gas. Let's clean this up a bit. Okay, let's balance this. So I've got 2, 3, 2, 3, 4. Okay, once it is balanced, you are then going to list your known and your unknown. What mass of aluminum can be produced from 2.4 kilograms? So 2.4, let's make that look a little bit better. 2.04 kilograms. And we're looking for mass of this. We're looking for mass of it in grams. So let's do this first by just converting the mass right off the bat. So this would turn into 2,040 grams. Okay, that's by multiplying it by 1,000 or moving the decimal 3 times over. So these are equivalent. Okay, so I'm going to do the problem where it's in grams. We are looking for mass of aluminum. Okay, I'm going to be back. I'm just going to throw the flow chart on here. Okay, let us begin. So we're going to start off with our known mass, which is 2,040 grams of aluminum oxide. Great, we now need to convert this into our known moles. We need to use molar mass. My molar mass of aluminum oxide is 101.96 grams per mole. So I'm going to use that in my Stoich statement. We are going to divide by 101.96 grams times mole. Okay, let's visualize what is happening here. Grams cancels out with grams, and from here to here now, I have moles of aluminum oxide, my known. Okay, we then need to convert to our unknown moles using a molar ratio. I have 2 moles of aluminum oxide, okay? And then I'm looking for aluminum, so I'm going to have 4 moles of aluminum. Oh, 4 moles of aluminum in the numerator. Okay, let's visualize what's happening here. Moles cancels out with moles. Moles cancels out with moles. Aluminum oxide cancels out with aluminum oxide. And so from here to here, I have moles of aluminum, my unknown. Okay, so we're at this stage here. Now, we are looking for our unknown mass. In order to convert moles into mass, you need to have molar mass. The molar mass of aluminum is 26.99. So I usually leave a little bit of room underneath my reaction just in case I have to list other things. Some students like to list all the molar masses at once. I like to wait because I don't want to do unnecessary work unless I absolutely need to. So I'm going to now take my molar mass of my aluminum and use it to convert it into mass. So I'm going to go 26.99 grams per mole. Okay, let's see what crosses out. Moles cancels out with moles, and I'm left with grams of aluminum. So now from here to here, I have mass of aluminum, which is my unknown. Okay, take a moment, plug that in, and see what you get. Now, my final answer that I get is 1,080 grams of aluminum. Now, we need to put our answer in A dot BC times 10 to the D form. So I need to change this into scientific notation. 1, 2, 3. This turns into 1.08 times 10 to the 3 grams. So A, B, C times 10 to the D grams. 1 is A. So if I were placing this in a numeric response, I put 1 in the first box because this would be my A, this is my B, this is my C, and this is my D box. So B would be 0, C would be 8, and D would be 3. So my final answer would be 1083. Okay, so this is my final answer. Okay, I'm going to show you one more way to do this problem. So let's say I did not convert that mass into grams right away. So this is something like if you were looking for, let's say, going kilograms to kilograms, 0.4 kilograms. Now, I'm going to start with my known, obviously. So 2.04 kilograms of aluminum oxide. Okay, now, if you feel uncomfortable doing this way, you don't have to do this way. You can most definitely convert it into grams. But I just want to show you this way if you want to take this as an option of knowing. So let's now convert this into my moles. So I'm going to use my molar mass, 101.96 grams per mole. Let me show you what's canceling. So from here to here, grams cancels with grams, and I am left with kilomoles of aluminum oxide. That's fine, because the kilo and the mole will combine, so that's fine. Then from here, I'm going to convert it into my moles of my unknown using my molar ratio. 2 moles of aluminum oxide, 4 moles of aluminum. Okay, so now from, let's see what cancels out. Aluminum oxide cancels out, moles cancels out, mole cancels out, and I'm left with kilomoles of aluminum. So from here to here, I have kilomoles of aluminum. Now, it just says I have unknown moles here. Okay, that's fine. I have unknown moles found. Okay, they're just in a different unit. Like I said, the units could be kilograms, kilomoles, millimoles, doesn't matter. Lastly, we need to convert to our unknown mass, and I'm going to use my molar mass. So 26.99 grams per mole. Mole, let's use a different color. Mole cancels out with moles. And now I am left with kilograms of aluminum. So from here to here, I have kilograms of aluminum. Plug that all in, I get 1.08 kilograms of aluminum. So that is the beauty of unit analysis. All right, this problem is for you to try on your own. When 6.5 grams of potassium chlorate solid breaks down into calcium and oxygen gas, what mass of calcium chloride, not calcium chloride, what mass of potassium chloride is produced? Okay, so take a moment, solve this one on your own. When you are ready, you can unpause and check your answer. Okay, so here's what I did. Step 1 was I wrote a balanced reaction. Step 2 was list my known and unknown. Step 3 was my Stoich statement. Okay, so I started off with my known. I used molar mass to convert it into moles. Then I used my molar ratio to convert it into moles of my unknown. And then I used molar mass to convert it into grams. And once I plugged everything in, I get a final answer of 4.0 grams of potassium chloride.